Hi everyone, and welcome to session 3 of our deeper learning, and today we're going to be focusing on the area model. Now today's session is all about bringing the different methods that you've used for multiplication together. So one thing that's really important with saying that you understand a module is firstly that you can use different methods, which you can, because we've done the formal method, we've done Nicolas Bones, we've done the grid method, we've done lots of different multiplication methods. And the next one is that you can explain how they are related. So the reason we're using an area model is because to find the area of a rectangle, we need to do something like, let's say that's 74, and let's say we've got 86 here. Now, I'm not writing the units, so millimetres, centimetres, because that's not really necessary for what we're doing at the moment. So in order to find out the area of this rectangle, I would do 74 multiplied by 86. So this is going to be my question for the day. So what does 74 multiplied by 86 actually mean? Well, this means we have 74 groups of 86. So imagine there's 86 cubes and we've got 74 columns worth of 86 each. Or it means we've got 86 rows of cubes where there's 74 cubes here, 74, 86 times. So sadly I don't have my cubes with me because obviously we're not at school. But let's imagine that my rectangle was a 3 by 2 rectangle. So here I've got 3 columns of 2 going across. I've got 3 columns of 2 circles. Or if I look at the other side, I've got 2 rows of 3. So there's one row and there's my second one. So I've got 2 rows worth of 3. So very similarly, here we've got 2 rows of 3. Here we've got 86 rows of 74. Here I've got 3 columns of 2. Here I've got 74 columns of 86. So what we're going to do now is we're going to use the different methods that we've done in these deeper learning sessions and try to relate them to this area model. I'm going to make it slightly bigger so it's easier to see, because I'm going to try to do all of these methods on the same board at the same time. Okay, so we've got 74 along here, 86 along here, and we know with it being a rectangle, there's 86 there, but there's also 86 there, 74 here, there's also 74 along here. Okay, so let's start with our formal multiplication. 74 multiplied by 86. Pause this and have a quick go at it yourself, see if you can get the answer before I do. So 6 multiplied by 4 is going to give me 24, so I carry my 2. 6 multiplied by 7 is 42 plus 2 is 44. And then because we're multiplying by 80, not 8, we put our 0 in. But after that, then we can say it as 8. So 8 multiplied by 4 is 32. So put my 2 in, carry my 3. 8 multiplied by 7 is 56. Plus 3 is 59. And we're going to add those together. So that will give me 4, 6, 13, so I carry my 1 and 6. So I've got 6,364 as my answer. So now what I'm going to do is I'm going to see where this fits in my area model. What does this actually mean? So this 444, to get this, we did 6 multiplied by 4 and we did 6 multiplied by 7. That's not actually 7, that's 7 tens. So we've done 6 multiplied by 74. And this part here wasn't 8 multiplied by 74, it was 80 multiplied by 74. And if we go back to our area model, so here we've got 6 groups of 74. Well, I know there's 74 across here. Let me just get rid of these bits so we don't get too confused. So I know there's 74 going across, and I want 6 groups of it. So what I'm going to do is I'm going to split this part and say that is worth 6, because then I've got 6 groups of 74. That means the rest of this is going to be worth 80, because I've done 86 take away 6 will leave me with 80. So 6 groups of 74 is 444, and then 80 groups of 74 is 5,920. So in essence, what I've done is I've just split my area into 2 parts, so into 2 rectangles. So let's have a look at the grid method. That was our formal. So you have a go, see if you can do the grid method and pause it, and then I'll go through it with you. So we need our multiplication sign, and then with the grid method, we're partitioning it into the 10s and the 1s. So I've got 74, 86. And you could have done these the other way around, so 86 up here, 74 by here, makes no difference. So 7 multiplied by 8 is 56, but because it's 70 multiplied by 80, it's 5,600. 6 multiplied by 70 is 420. 80 multiplied by 4 is going to be 320. 6 multiplied by 4 is 24. I'm just going to rub out this inside part because we're going to be using the same rectangle for each of these questions to show how they are related and why they equal the same answer. So to get my answer here, I need to do 5,600 plus 320 plus 420 plus 24. So that'll leave me with 4, 6, 13 and 6. So again, I've got to the same answer, which means it should fit into this area. But what do these values actually mean? Well, 5,600, I did 70 multiplied by 80. 320, I did 80 multiplied by 4. 420, I did 70 multiplied by 6. And 24, I did 4 multiplied by 6. So what I've done is here, I can see I've got 6. So I want to do 6 multiplied by 70. So if I have this line back where we had it before, this is 6 groups of 74, but I only want 70. So I'm going to cut off a bit and say that this part is worth 70 and this little part is worth 4. So 70 multiplied by 6 is 420. And then 4 multiplied by 6, because this part will be exactly the same as that part. So 4 multiplied by 6 will give me 24. And then here I've got 80 multiplied, let's look at this one, 80 multiplied by 70. If I carry this on, this part will be exactly the same. So 70 along there and 4 along there. So this rectangle is worth 80 multiplied by 70, which is 5,600. And this part is going to be worth 4 multiplied by 80, which is 320. So the only difference between these two methods is actually it's just partitioned it in different ways. This has 4 rectangles that it's been split into, whereas this previous one was only split into 2 rectangles. So let's now look at Napier's bones. I'm going to just get rid of this part here so that we've got a little bit more room. So for Napier's bones, it's a similar layout to the grid method. However, it's a bit backwards. and it uses the digits rather than the values. So instead of 70, we've just got the 7. If there's any of these methods where you're not sure about them, go back to the previous video and see if you can go over them. But you have a go at Napier's Bones and pause it, and then unpause it when you are ready. Okay, so 4 multiplied by 8, it's going to be 3 10s and 2 1s. 4 multiplied by 6, it's 2 10s and 4 1s. 7 multiplied by 8, 5 10s, 6 1s. 7 multiplied by 6, 4 10s, 2 1s. And then I do my diagonal line here. And then I simply use column addition to add up each of my digits. So I've got 4, 6, 13, carry the 1, and 6. And you can see that I've come to the same answer. So how does this one work? Well, this part here is 4 1s multiplied by 8 10s. So that is actually 32 10s. And 32 10s is the same as 320. The next part, we've got 4 1s multiplied by 6 1s, which leaves me with 24 1s. That's just 24, which is this part. This one is 7 10s multiplied by 7 10s. Oh, not 7 10s, 8 10s, because it's 70 and 80. So that will give me 56. Now it's not going to be 10s because 10 multiplied by 10 is 100. So 56 hundredths, which is 5,600. And the last one, 7 10s multiplied by 6 1s is going to give me 42 10s, because 10 multiplied by 1 is just 10, which will be this part. So actually Napier's Bones is very similar to the grid method because it splits them into exactly the same rectangles. So let's just write Napier's Bones. The next one we're going to look at is the Chinese method. So I'm going to do 80, 1, 2, 3, 4, 5, 6, 7, 8. So there's 80 and then 6. 1, 2, 3, 4, 5, 6. And then for my 74, oops, it's going to be 1, 2, 3, 4, 5, 6, 7, and then my 4 will be 1, 2, 3, 4. So I've got 74. And we know that this section here is going to be the ones. This section here is going to be the hundredths. Then these two sections, when added together, will be our tens. So if I look at my ones, I've got 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4. So 6 multiplied by 4 is going to give me 24 ones, which is that section. For my hundreds, I've got 1, 2, 3, 4, 5, 6, 7, 8 by 1, 2, 3, 4, 5, 6, 7. So 8 multiplied by 7 is 56. So I've got 56 hundredths, which is the same as 5,600. So now I'm going to guess that my tens is going to be 740 altogether. It might be 420 and 320, or it might be different values which add together to make my 740. So let's check it. 1, 2, 3, 4, 5, 6, 7, 8 by 1, 2, 3, 4. So that would be 32 tens. And this is 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6, 7. So that's 42 tens. So actually I can see 42 tens is 420, 32 tens is 320. So I don't even need to add these up because I can clearly see those. So actually, the Chinese method, again, feels the same as the grid and the Napier's bones because it splits them into exactly the same rectangles. Now, the Egyptian method is a little bit different. So I'm actually just going to rub this out and start my rectangle again, because this is the one which is the most different to the others. So let's draw my area again. So I had 74 by 86. So for the Egyptian method, we have 74 multiplied by 86. So I need to start with my 1 and I keep doubling until the number is larger than 86. So 1 doubled is 2, doubled is 4, doubled is 8, doubled is 16, doubled is 32, doubled is 64, doubled is 128, and that's larger than 86, so I can stop there. And then I'm going to do 74, and again I'm going to double each time. So 74, 148, 296, and don't be afraid, as I've said before, to do column addition on the side, just to make sure. 592, 1184, 2368, 4736, and 9472. And then what I need to do is I need to look at this 86 and see which of these numbers will add up to 86. Now I always start with the largest number I can, just that there's not too many numbers. So I'm going to say 64 plus, and then let's do 16. So that would put me on 80, so I need 6 more, so plus 4 plus 2. So 60, 70, 84, 86. And then what I need to do is I do 74 multiplied by 64, so 74 by 64, plus 74 multiplied by 16, plus 74 multiplied by 4, plus 74 multiplied by 2. And then I'm going to write these answers in column addition. So 74 multiplied by 64 is going to be 4,736, plus by 16 it's going to be 1,184, by 4 is going to be 296, and by 2 is going to be 148. And then that's 10, 16, 24, carry my 2, so that will be 10, 17, 26, carry my 2, 7, 9, 10, 11, 12, 13, carry my 1. And again, I've got exactly the same answer, just through a different method. So what I need to do now is I need to see, how does this relate to my area model? Well, I started off doing 74 multiplied by 64. So here's my 74, but I want 64 going down. So I'm going to take up this part, 64, and I know 74 multiplied by 64 is 4,736. And then I've got 74 groups of 16. So let's say that's 16, and that's 1,184. And the next one is 74 groups of 4, which leaves me on 296. And then the last one is 74 groups of 2, which leaves me on 148. Again, I've used exactly the same area, but the Egyptian one has just split it into groups of 74. So you have 64 groups of 74, 16 groups of 74, 4 groups of 74, and another 2 groups of 74. But they all equal the same answer. So I hope you followed all of that. If there was anything, any of the methods which you didn't quite remember, go back and look over those videos again. But I'm really impressed that you've sat through all of this, because this is the real depth which shows why you are able to use so many different methods for one simple sum. Well done.